Hi there, welcome back. Well, I'm going to start this video with a little bit of the electronics, which is always better than the cleaning and cabinet restoration, which is awaiting me. And what I want to do now is I want to look at this, the power supply section, which, if you recall, I bypassed a couple of steps in the beginning. One of them was the Selenium rectifier. I decided to leave it in to see how it worked, and it does work. It hasn't smoked yet. And the other one was the filter cap, which even though it doesn't seem to be giving me any problems, it doesn't seem to be creating much hum. I obviously still want to change that because I don't trust those capacitors in there. So what I'm going to do now is I'm going to measure the B+ just as it is on FM and on one of the AM bands. And if I remember correctly, one of them was supposed to give us 270 volts and the other one 278, if I'm not mistaken. So what I want to do is I want to see what it gives me now, and then I want to change the Selenium rectifier to a silicon bridge rectifier and see what it gives me then. Because I may have to put a resistor in series here to reduce the voltage. I've got everything set up here. I've got the volume on 0. I don't need to hear it. I just want to switch it on and see what B+ is as it is right now. We'll also get an indication of the AC component of the B+, so we'll get an idea of what sort of filtering we are getting or not getting at this point, and we can compare it to later when we have the capacitors in place. So let me connect the dim bulb tester. I've got, well, let me give it 2 light bulbs, and I'm going to put it on just long wave. So that should give us 1 B+ for the AM bands. Obviously it's still high because the tubes haven't started drawing current yet. And it will then be lower than we want because we have some restriction on it. The radio is seeing 195 volts at the moment. It's drawing 150 milliamps. And we've got 229 volts. So let's reduce the restriction. It's gone up to 260 and the radio is seeing 217 volts. If I bypass the dim bulb completely, (267, 68). Well, actually that is pretty close. And it's giving us 2.2 volts ripple current, ripple voltage. So what do we have here? I think it's stabilized. 266, 267 with 2.2 volts AC ripple. It's drawing 190 milliamps. So let's just quickly summarize. On AM, and I think this doesn't change if you put medium wave or short wave. No, it doesn't. We are seeing 225 volts, 190 milliamps from the AC. The B+ is 265, 266, 2.2 volts AC ripple. And now if I change it to FM, it drops. And we are now seeing 224 volts AC. This is actually low today. It should be around 230. What if it's got the bloody virus? Anyway, 224, 200 milliamps, it's 260 volts and 2.5 volts ripple. So what I'm going to do next is I'm going to change the Selenium rectifier and the capacitors, put new capacitors in there, and then we'll compare what the results were. As I said, we may have to reduce the voltage by putting a resistor in line there. And that's always a bit tricky because you can't really calculate it. You sort of got to go by trial and error. but we'll see what results. I'm losing about, what is it, 10 volts, 18 volts? Okay, let me get on with it. All right, I have replaced those capacitors. I've put two 47 microfarads in place of the 2x50s, and I've replaced the 4 microfarad, which is the filtering for the ECC83B+, with a 10 microfarad, and I will show you. I have not removed the existing cap, I've just disconnected it completely. I will show you in a second how I fitted that, but first of all I want to test this now. And to do that I'm going to put full restriction on again, because I'm not that stupid. We want 270 and 278. And my guess is going to be a bit higher, so long wave. With full restriction, and we'll take off restriction as we see things come under control. The tubes are just about to start conducting, and you can see the lamp going brighter, but it's not a short, so I'll reduce the restriction. Seems good. Reduce it again. Now you see that's quite high. 296, and I've only got 213 volts coming in there. So I've got to reduce this voltage. If I put FM on here, 289. Yep, that's too high. What it's drawing at the moment is 200 milliamps, which is 42 watts at 211 volts that it's seeing in there. The schematic says about 50 watts. So we're okay there so far. But yeah, this thing is a little bit too high. Let me just go one step further. Yeah, it's going over 300 volts. So that selenium rectifier was definitely reducing the voltage quite significantly. There was a big voltage drop across it, is what I mean. So I have to put a resistor, and what I think I'm going to do, I'll have to see where I'm going to put it in. I've got to put something that's pretty beefy, because it's going to dissipate quite a bit of heat. How much it's going to dissipate, I don't really know, but I can guess. Let's say I've got 310 volts. I want to drop 30, 40 volts. That's quite a bit. That is quite a bit. Bloody hell. Almost better to backwind a winding on the transformer. The problem with this is that it's only got a 220 volts input. It doesn't have a 240, which would have been very useful, because that tends to solve the problems just by itself. But it doesn't. So I'm going to have to see what I'm going to do about a resistor, and I'll get back to you. So here's the setup I have now. This is the replacement I did. I put a selenium rectifier in there, bridge rectifier. And this thing is quite capable of handling the current. The maximum current's about, 79, 80 milliamps. And I have the positive, or the positive coming out. I've disconnected it from the first filter cap. And the crocodile clips take it to resistors. But I just want to show you, I've connected the two caps to a very solid ground lug over there, as well as the ground of the selenium, of the bridge rectifier. So it's pretty solid. And the 4 microfarad I haven't put here at all. I've actually connected the 4 microfarad, or rather I've used 10 microfarad, right to where it went to on that tag strip, and connected to a ground, which is exactly what it was doing on the other side. Now, what do we have in voltages? Well, we've got full voltage bypassed over there. It says 223 to 225. It should be about 230. But because everybody's at home, I'm wondering if that's not the reason. And we are getting on FM 271, we're supposed to get 270. That's pretty good. Now, I expect it to go a little bit higher when that goes to 230, but it shouldn't be too bad. Now, if I turn it to long wave, now long wave I'm supposed to get 279. And that's it. That's it. The problem is the resistor I've had to put in there is actually two resistors, and they are fairly high. The white one is a 5 watt 220 ohm, and the sort of brownish one is 56 ohm. So I've got a total of 276 ohms here, which is actually quite high compared to what I'm used to. I'm used to sort of getting by with 100 ohms or something. And I don't have one resistor that'll give me that. So I'll need to get one that I can bolt onto the chassis, one of those with a heatsink. And I just want to see what sort of power we're dissipating here as well. I've connected the multimeter across the two resistors. And we are getting an 18, 19, call it 20 volt drop. So that is V squared over R, so 20 squared is 400 divided by 200 and, what is it, 76? So it's not much power, but it does heat up because it's constant. So I'm going to probably use a 10 watt, just for safety. I know it's overkill, but better overkill than end up with a problem. So that's been determined, and we can now move on. When I get that, I'll fix that resistor probably somewhere here on the chassis to use the chassis as a heatsink, and then just connect the 2 points between where those two crocodile clips are connected to. And we should have our voltage problem solved. Well, here it is, folks. This is the final solution. I found that the one electronic supply store we have in Madeira is closed. I wanted a 300 ohm resistor, and I had to make do with a 470 in parallel with 820, which I believe gives me 298. Not bad. The other thing it does is it makes it effectively almost a 10 watt. These are 5 watt each. They will get warm. The 470 will obviously get warmer than the 820, but some of the power is somewhat dissipated. So the B plus comes out of the bridge rectifier, goes to the resistor, through the resistor, and it goes to the first cap, the B plus. The takeoff from the B plus is that sort of pinkish wire at the back there. So we're all set to test. Now our supply is back to 232, so I guess most people in the building must have switched off their heaters or their kettles. Anyway, time to start this up. I've got that ready, I've got full limit. I'm going to put on long wave. And we should start getting the tubes conducting soon. There we go. Give it another lamp. And another. And another. 271. Now I'm going to bypass it. And remember, we want 278. Now that's near as damn it. 280. Pretty good. I'm happy. And now I'll put on FM. 280, and FM should come down to 270. Well, it said 270, 271. Well, that was closer than I expected. And just as well that worked, because I didn't want to put this on standby till the shops opened. 270, 271. Brilliant, that's working. And I'm just checking the temperature of those resistors. Obviously it'll get a bit warmer, but it's at 39, 40 degrees. I can live with that. 41, 42, 41. So our supply is sorted. The selenium rectifier is out. The capacitors have been replaced, although the old one's left in place there, but totally disconnected. And I think we're about ready to move on. Right, time for the FM alignment. We are nearly finished. Everything to do with electronics here. So I'm quite anxious to get this part done. And the FM alignment is actually described quite succinctly in the service manual. There's not much to it really, the way they describe it. However, it did pose a few doubts. Because basically what they're doing here is they're asking you to put in a carrier. They say AM or FM or unmodulated. Now, I really don't understand what or unmodulated means. I see it as just a carrier. 10.7 megahertz carrier. Okay, get that out of the signal generator, and they say connect it to the grid 1 of the EBF89, and then you tune A to a maximum, B to a minimum. But this B is now if you have AM. And the way I understand it is that B, what you're trying to do is you're trying to get the ratio detector to reject AM. So I believe you put a modulated signal in there and you tune it so you get the least amount of AM of audio if you have it AM modulated coming out of your speakers. That's the way I understand it, in order to get a minimum. Now there is A. That's the A coil, and there's B. Now B is the one where you're trying to adjust the ratio detector to the point on the curve that will give you the best audio. And one way to measure that is to get it to reject AM modulated signals. And I think that's what they're trying to do. I have to admit, this particular setup with a pot over here, I understand what it does. It's trying to balance the two, but I must admit it's not something I'm too familiar with. And I've done a similar one, a similar IF alignment for the FM on a Grundig 4198, I think it was. I went into great detail into how that FM alignment works. So I'm not going to go into full detail on how it works here. But if you want to see pictures and arrows and all that sort of thing, go and look at that one. I'll link it above. So what you're trying to do is trying to get this section here to reject all AM, because what you want is FM, obviously. And the way I understand it is you measure the voltage. You put a voltmeter across this capacitor, the ratio cap, which, by the way, I did change. I changed it to a 4.7 microfarad because I just didn't want to leave an old component in there. And just so that you know, after many changes here, I still put this bloody cap in backwards. And luckily, when I did a recheck, I was just trying to find out where this, what value the spot was set at. I did find that this was the wrong way around. It happens, so be careful. What I did find was this pot was set to 790 ohms, which kind of defied my logic, because I believe that this pot was here to balance that and that diode. In other words, you wanted these two diodes to be exactly the same. And because they probably won't be, they're germanium, they're made a long time ago, and they're not in the same package anyway, you would need to balance the effect of the diode and that resistor, which is a known resistor, with this diode and an unknown resistor, a variable. And my logic was that this would probably be close to 220 ohms. You know, a little bit less, a little bit more, depending on the characteristics of this diode compared to the characteristics of that diode. As it happens, it's like 3 times more, and I don't really understand it. So I'm not touching it. I am not going to mess with this resistor like I didn't do with in the alignment of the radio that I just linked, because sometimes you've got to leave well enough alone, and I really don't understand it enough to be able to mess with it. So what you do is you measure the voltage across this cap, and really it's the voltage from the negative contact of this capacitor to ground, because that's where that is set to, and you adjust various things to get a maximum negative DC voltage. Now, the stronger or the higher the negative DC voltage you've got here, the clearer the signal's coming through. In other words, you use the magnitude of this DC voltage to indicate how well tuned the coils are. So this one here, I'll leave that well enough alone for now, because this one I'm going to use to try and adjust for a perfect sine wave, as I've described in the alignment of the other radio. So this one I will align to get a maximum DC voltage across here, and then if we move backwards, you then align C and D, these two. But what they want you to do is they want you to inject the signal into grid 1, this point 2 over here, of this tube, so you're only adjusting the alignment of that setup. Then you go back and you inject the signal into the grid of the ECH81. It'll be a lower voltage because there's gain on here, and that'll go through those two, and when it goes through those two, you align those two, D and C, for maximum as well. When you've finally done that, then you go to the ultimate origin of this, and you've got to align these two, which is the coupling between the FM front end and the actual input to the ECH81. And the way to feed this signal is to lightly couple it around this tube. And what I've done there is I've got a little coil. I put the coil on like a cap as in a hat, over the tube, and that sort of capacitively couples it. I don't actually feed it into this grid or anything like that, and that's usually enough. So I'm going to set things up and we'll get on with it, because it tells us to achieve a maximum on A, and it tells us then to move to the grid of the ECH81, and you get a maximum on C and D, and then it tells us to lightly couple to the ECC85, or you can actually inject it through a 0.5 picofarad capacitor to point X. And point X is actually conveniently indicated over here. And I'll be quite honest with you, I don't know where it is on the chassis, but I'm sure we could find it. In fact, it might be indicated on the other diagram. But it does tell you a few other things here. You can use an ammeter instead of a voltmeter. I've got a voltmeter, so I'm using the voltmeter. It tells us how to set the ratio stage, primary and secondary. You should inject 100 millivolts into the grid 1 of BBF89, in other words here, 100 millivolts. And it tells you to adjust the pot R3 to 300, 400 millivolts, and I don't understand this, and I've had a chat with a friend of mine who also does these radios. He's also South African, and but he lives in Germany, and he speaks the language, and we both sort of cracked our heads together to try and figure out what this meant. And quite honestly, sorry Derek, we sort of understood it, or I sort of understood it, but not enough to risk messing the whole thing up. So I'm leaving it as is. This is the setup of the alignment coils on the IF transformers. On here it's pretty simple. There's C is from the underside, D is from above. On this side, B is on the underside. Now B is the one where you adjust to get the best or least distortion. But A, which you want a maximum from, you've actually got to do it through the wiper of resistor R3. It's a little variable resistor, a little pot. So you've got to be very careful here. And of course, these things are filled with wax, which doesn't help. Now here we have the FM front end, and that's useful because that tells us where the other two are. So we needed to do E and F. There's E. When you look at it from the side, that's E, that's F. And in fact, they tell you here where point X is if you want to inject it directly into point X. I won't be doing that. I'll be putting the little coil over the ECC85. So time to move on. Let's get this set up to do the first alignment and see how we go. So let's start off with the signal generator. We've got a 10.7 megahertz carrier being produced. The amplitude, I'll leave it at 100 millivolts RMS, which is what they ask you to do in the first stage. There's no modulation, but if I wanted to do modulation, and I will want to do modulation when I do the final test, I'll go to modulation, choose FM. I will give it a 50 kilohertz deviation, and this is, well, I suppose you give more or less, but the tone that I want to modulate on there is 600 hertz, and it's a sine wave tone. So at the moment, that's what it'll produce, but I'm going to deactivate the modulation because I just want the carrier. And that's coming out of channel 1, so I can just activate it by activating the channel. I'm actually running it through the little attenuator, but it's got zero attenuation at the moment. I'm just using it for the AC coupling. So in other words, I'm using this just for the capacitor that's inside to block DC coming back or going out from the set. I want the signal to be fed into the grid 1 of the EBF89s. That is actually that pin over here. On the leg of that 10 ohm resistor, there's a 10 ohm resistor over there. So I'll put the positive there. I can put the positive now because I know it's AC coupled. I'll find a convenient ground point, which can just be the chassis over here. And I try and get in there without shorting, but the radio's off. It's not a problem at the moment. And there it is. Now to measure the voltage, I've got to measure on the on that capacitor, and the place to find it would be over there. One leg of the capacitor, this leg over here, is actually connected to ground. This is a ground point. So I'm going to put the multimeter on the negative of the multimeter on ground, and the other leg goes to up there. So I'm going to clip the meter to that, and that'll give me that voltage. Now the meter I'm going to set to DC volts, but because I expect a negative voltage, I'm going to reverse the polarity because this thing only flows one way, and I'm going to put it on 10 volts for now and see what we get. So I'm switching on the dim bulb tester. It's set to FM. Volume is on minimum. We don't need to hear anything. We just want to see if a DC voltage creeps up. It's too little voltage on there. I haven't switched on the signal generator yet, but we should get something on here. And I'm going to give it, there we go, we've got some. It helps when you switch that on. When I've got leads going into the bottom and this thing is powered, I get nervous. You might have noticed that if you've seen any of my other videos, and I sometimes forget simple things like switching on a meter. Okay, we've got what that'll be a minus voltage. That'll be minus, what is it, on 10 volts, so minus 1.3 or something like that. And I'm going to, just to make sure we get this thing aligned properly, I've reduced the restriction on the current limit as much as possible. And we still got minus 1 point something. I can actually put this on the 3 volt range. That's 1.4, minus 1.4. It's on that second line over here. And if I increase the carrier signal that I fed in, that should go up. 110 millivolts, 120 millivolts, 130 millivolts, and so on. So leave it at 100. And I'm going to tune that top one, that is coil A. And I've got to do that very bloody carefully because it goes through that little trimmer pot. So let me fit this in there. No, that's going the wrong way. Let's try it the other way. It's very stiff. There's still wax in there. It's going through. Let me go back. That seems to be it. That I think is peaked. Not much to it. But I don't want to mess too much with that. Okay? Because, yeah, I don't want to mess too much with that. All right, next. Next, they tell you to connect the signal into grid of the ECH81, which is actually pin 2 that guy over there. So I'm going to do that, and I'm going to reduce the signal level from 100 millivolts down to about 10 millivolts, because usually it's you've got amplification, so you've got to feed in a smaller signal. And we'll do the same thing for the respective cores, which will be C and D, one on the underside, one on the top end. Now to adjust the front end ones, E and F, you're supposed to lightly couple over the shield of the ECC85. And the way I do it is I take the signal generator, I've got a little coil here wound inside this paper former. It's about, what, 10 turns of wire. Comes out here, and I actually connect the signal generator to that. It's pretty homemade, but it works. And you just slip that literally over the head of the FM front end tube, the ECC85, and that's lightly coupled. Now you've got to be careful, because this is coupled capacitively. It's not an absolute value. In other words, you put it on, if you move anything, even just moving the chassis, the actual signal changes. So you've got to be careful. Keep this not firm but fixed, and don't get too worried about the actual value. Just look for a peak. So let me do that. Now I have only 4 millivolts. I'll switch on the set. I always switch it off when I take these crocodile clips out the bottom. You never know when you can get zapped. So I'm ready to make the adjustment, and I just want to let it warm up. It's not seeing much there, for the simple reason that 4 millivolts lightly coupled is practically invisible to the set. So I'm going to put in 20 millivolts, a little bit, 50 millivolts, better. I'm going to put 100 millivolts, much better. Okay. Now you see any movement on here. This is me just moving the cable, just adjust it a little bit. So let's start with E. Okay. Oh, wrong way. Oh, that's it. That's about as good as it's going to get. Very little. Very little adjustment necessary. Let me try the other one. That'll be F. No, wrong way. That seems to be about it. Not much there, not much to change, which means it was probably set right in the first place, and it hasn't changed at all. Just so you know, the ones I was changing were E and F according to the drawing over there is that one and that one. And you've got to be careful because they're right in there. I actually put a torch to see it and clean some of the wax, and then one of them's got wax, had wax. So I went in and cleaned that up. Now what I want to do is I want to see if I do anything to the last section, which is the one where you're literally trying to tune the discriminator, the ratio detector. And that bugger is that guy over there, which has still got wax in it. I haven't cleaned it. I haven't changed it. I haven't touched anything there, in fact, in that one. So what I'm going to do is I'm going to put everything up with a scope now. I'm going to change the connection to the EBF89, and I'll tell you why. Because I'm only going to adjust, this is the adjustment for the end bit. There's no reason why the signal has to come through the entire radio. It can actually just go into the grid of that tube, which is the preceding tube, which is that G2. I'll switch this off again to make sure we don't have any mishaps. And I'm going to do the same as I did before, which is connect this to a convenient ground point. Make sure it doesn't slip out. And connect this to that G2. And if you recall, they said 100 millivolts. They wanted 100 millivolts on there when we were testing. So I've set that to 100 millivolts. And now we've got the signal coming out of the scope. I'm going to switch it on. What you're seeing there is the audio output. We're seeing the signal across the speakers because the speaker comes in here, then goes to the speaker. I've chosen speaker as opposed to dummy load. And I've got the that channel of the oscilloscope monitoring that speaker. Okay, volume is, well, it doesn't make much difference. We're just seeing some noise and I'm putting it up to maximum. I'm going to reduce the volume on the radio because I don't know how loud it's going to be. I'm going to activate modulation, and what I'm doing is sending a 600 Hertz tone FM modulated on that 10.7 megahertz carrier. So effectively, this is like the information coming through on my radio station. And I've activated. And we see nothing because I believe I've still got the volume very low. And there we go. And we can hear it because I've got speaker. Let me put it on dummy load so we don't have to hear that noise. And look at that. Look at that. I don't know how far I can go before it clips because I'm not. Okay. Wants to go a bit more? That's fine. I'll give it to you. Look at that. Bloody hell. That sine wave is perfect. Now what does it tell us? Well, it tells us that the ratio detector is well tuned. Could it get better? Maybe. But I'm not going to find out. I seriously am not going to touch that. I have aligned radios where the result hasn't been as good as this. So, we don't need to adjust that at all. Well, I don't. Because I'm happy with it. We're transmitting a 600 Hertz tone. And it's FM modulating the carrier. And then it's doing the ratio detection, it's decoding all that, sending it through the amplifier, and we're getting a nice 600 Hertz tone coming out the other side. And you know what? You couldn't get better than that. So I'm leaving well enough alone. I am happy. I'm happy. And that means that in terms of electronics, our restoration is done. All this is going to be put away. The meter. The scope is going to get switched off. Signal generator becomes redundant now. We are finished with the restoration of the good bits. Unfortunately, I still have the bad bits, which is the cabinet. But I'll do that. I'll do that in another video. I need to find a bit of motivation for that. I think what we can do before we end this video off is listen to a bit of FM and see what it sounds like. Yeah, let's do that. Starting at the lower end, 87 megahertz. That's the first station I usually get over here. Can't play music. Bloody hell, I want talk radio. Come on, guys. This is actually one that I don't receive too well anyway. Music. A lot of bass on there. Bloody hell. I want to get a talk radio station to test out the tones, but I can't. Well, can't stop there for fear of copyright restrictions, but it sounds great. It actually sounds too bassy, and that makes sense. I haven't played with the settings over here. But there's also one other aspect, and that is that the high frequencies will be coming out of the tweeters. You know, the electrostatic tweeters on the radio, and I haven't got those connected. Mind you, the speaker that I'm using is full range. It's actually just a two-way, so it should pick up all the frequencies. But I wanted to get an opportunity to test the audio, and yeah, we'll do that at the end when I get some copyright-free music, and I'll transmit it from the little transmitter that I have. It's actually one of those car transmitters. It works very well for these tests. Now we have to say goodbye to this chassis for a while because I've got to tackle the cabinet, as much as it pains me to say so. I've got to tackle the cabinet. I've got to strip the varnish. I've got to get down to the veneer. I've got to do all sorts of crap on there, and I don't really like it, but I have to do it. And what I'm going to do is I'm going to do that mostly off camera. If anything interesting comes up, I will record it. And so the next time we see this, it should be inside the cabinet and ready for the final demo. Well, that's another video done. Thanks for your company. Thanks for watching. Thanks for the support. Thanks for the comments. And if you do enjoy this, please subscribe. And if you like it, please click like and share and all that jazz. And if you want to support the channel directly, you can do that on Patreon. So, thanks for watching. Bye for now. Stay safe.